Hi, this is Gigi from Kauai Community College. In this video, we are talking about the derivative of inverse cofunctions. That means inverse cosine, inverse cotangent, inverse cosecant. So before you actually watch this one, make sure you watch the previous ones like inverse sine, inverse tangent, and inverse secant first. Okay, so here we go. Before we do this, we are going to do a little investigation. And I have the unit circle there for you to look at. Okay. So we want to investigate something here. What is inverse cosine of x plus inverse sine of x? That's the question we're asking. So then suppose x is 0. So we're looking, x is 0. We're looking at what is inverse cosine of 0? So that means when is cosine 0? Which angle has cosine at 0? You would be right here, right? Pi over 2. So cosine of 0 is, inverse cosine of 0 is pi over 2. And inverse sine of 0 would be 0, right? When is sine 0? Sine 0 when it is 0. So you're here, right? So that's what the chart is saying. So then cosine, inverse cosine plus inverse sine is going to be pi over 2 plus 0, which is pi over 2. Okay, now, next we have inverse cosine of 1/2. So the question is at which angle, when is cosine a half? Cosine a half, cosine is on the x value, cosine a half when you are at pi over 3. So that would be pi over 3. And then inverse cosine of 1/2. When is sine 1/2? Sine is 1/2 when you are here at pi over 6. Pi over 3 plus pi over 6. If you keep 6 as your common denominator and you multiply this by 2 over 2, so then you will have 2 over 6 plus 1 over 6 is going to be 3 pi over 6, or we will call that pi over 2. Is that always true? What are you thinking? Let's think. Next, one more before we see a pattern here. Which angle will give you a cosine of square root of 2 over 2? And that must be pi over 4. The same, pi over 4, I mean to say pi over 4. And this is also pi over 4. A quarter plus a quarter is a half, and that is pi over 2. Okay, so you can do the other ones, but what about negative? Will that work? How about negative 1/2? Okay, so when is cosine negative 1/2? Negative 1/2 right here on cosine on the x-axis, and cosine is negative 1/2 when the angle is right here, 2 pi over 3. Okay, and remember cosine, we're looking at the top half of the circle, 2 pi over 3. Now, when is sine negative 1/2? Sine negative 1/2 is here. So we're looking at this angle right here, but we cannot call it 11 pi over 6 because for inverse sine, the answer needs to be in between negative pi over 2 and positive pi over 2. Those are your values, the range of inverse sine. So instead of calling it 11 pi over 6, you'll need to call it negative pi over 6. Okay, so then 2 pi over 3 minus pi over 6 2 pi over 3, when you multiply, that would be 4 over 6. Common denominator is 6, and you would subtract, you'll get 3 pi over 6, which is pi over 2. So it will work also when you have negative values. Okay, so I think that's enough, and you can fill in the other lines if you like, but would you believe it? If we say inverse cosine of x plus inverse sine of x is pi over 2, is there any logical reason why that should be? I'm going to let you think about that, but that is correct. That is an identity in your trigonometry class. You should see that. Okay. Now, given that inverse cosine plus inverse sine is pi over 2, that is an identity, right? So we can go and take the derivative of both sides. And what we are interested in is what is the derivative of inverse cosine. Okay, so on the first term there, we will have the derivative of inverse cosine, which we don't know what it is, so just leave it the same, is plus the derivative of inverse sine is something that we know. Okay, then what we're going to do is subtract the thing over, so then the derivative of inverse cosine is the opposite of, this is the opposite of the derivative of inverse sine. Okay, so that is something that is pretty cool to you know, so you only have to memorize really the derivative of inverse sine is 1 over 1 square root of 1 minus x squared, and then the derivative of inverse cosine is just the opposite of it. Okay, similar things can be said about tangent and cotangent, inverse tangent and inverse cotangent. And you can also prove that the derivative of it is just the opposite. Okay, so you really only need to know these three, and then these will be just the opposite of the ones on the left. That's pretty cool.